Okay, here's the first worksheet, worksheet number 1 on graphing exponential. Exponential functions. Okay. Well, exponential functions, what word do you hear there? Well, the word exponent, right? Exponent. All right, and we know what an exponent is, right? An exponent, like you have, it's like a power, like, 3 to the power of 2, right? This is your exponent right there, the exponent. But the exponential functions you're going to see has actually, let's say, for example, you have f of x is equal to 2 to the power of x. See, the ones you're going to see that the variable, or the x, is up here in the exponent. The variable is up here as an exponent, and that's why these are exponential functions. All right. First thing before we start looking at these is I want to talk about negative exponents. Right, because it's going to come up. All right, so something like this. Well, what is 2 to the power of negative 1? Remember, when you have a negative exponent, if you remember from Algebra 2, we can interpret it. We don't interpret negative exponents. So what you have to do is actually, if you remember from Algebra 1, we put a 1 under it. We put a 1 under it, and to make a negative exponent positive, you move everything. If it's in the numerator, it becomes in the denominator. So 2 to the power of 1 is really 1 over 2 to the power of 1. This doesn't flip, right? When this comes down, well, we always have a 1, and then this comes down. So the answer is 1/2, right? If you had 2 to the power of negative 3, that would be what? That would be, well, 2 to the power of negative 3 over 1. We bring it down, right? And that would be, there's nothing left up here. We put a 1 over, and now this is 2 to the, and now it's positive down here. Okay, so that's kind of what we learned back in Algebra 2, and then 2 to the power of 3 is 2 times 2 times 2, so that'll be 1 over 8. Okay. Well, what you're actually going to do is actually go backwards. You're going to start with this, right? So if I have like 5 to the power of negative 1, well, that would be 5 to the power of negative 1 over 1. This comes down. That would be 1 over 5. It would be 1/5, right? 1 to the 5 to the power of a positive 1 is, well, 1/5. Okay, but now we're going to go backwards. You're actually going to start with the fraction. So if I have a fraction now, let's say 1 over 7, whatever. Well, I don't want a fraction. We want to just have a base and an exponent, right? We want a base and an exponent. The exponent's up here. I don't want a fraction, but you can always write a fraction with an exponent, right? We know that this is 1 and 7 to the power of positive 1. And then now what? Now this can move up, right? I'll just do an extra step. This moves up. But again, remember, when you have an exponent, and if it moves, if you move it from the numerator or to the denominator, it changes from negative, it changes sign. So here, in this case now, this one's positive. When I move it up, guess what's going to happen? It'll be 7 to the power of negative 1. It'll be 7 to the power of negative 1 over 1. Well, that's just 7 to the power of negative 1. okay? So I'm kind of just breaking it down to all the steps, but I mean, simply put, 3 to the power, 1 over 3, right? We're starting with the fraction is the same as what? 1 over 3 is the same as 1 to 3 to the power of 1, but when I move it up, it'll be 3 to the power of negative 1, yeah? 1 to the power of 2, or 1/2 would be 2 to the power of 1, right? Because it's positive here, and then when you move it up, it'll be 2 to the power of negative 1, right? That's what I'm talking about. You're going to be going backwards. You don't want a fraction. We want a base and an exponent. A base and an exponent. Okay. Okay, and continuing, you won't see this scenario, but same idea. If you have 1 over like 4 to the power of negative 2, or any negative number, again, we don't want a fraction, we don't want negative exponents. Yeah, this would move up. See, now it's negative here, but when you move it up, it's what? It'll become positive. That would be 4 squared over 1, and then we know 4 squared over 1 is just 4 squared, and then we get an answer. We'll get 16. You won't see these too much. You'll really just see fractions. Fractions like 1/3. Well, that 3 has an exponent. If it doesn't have an exponent, it's a 1. And then you move it up, so it'll be 3 to the power of negative 1. Okay, that's mainly what you're going to see. Okay. All right, so for this assignment, all I want you to do, and this is kind of more like an exploration assignment, just to see the behavior of these graphs, right? You're learning these new graphs, these exponential functions. Here's your worksheet, right? Here's what your assignment looks like. And I got 3 to the power of x, and I got 4 to the power of x, and I got 2 to the power of x. All I want you to do for these, I know it says sketch a graph, and like you don't know what these graphs look like yet. You're learning, right? This is why it's kind of like a exploration assignment, like activity. Exponential functions. Okay. I want you to do something from old school, back from Algebra 1. I want you to make a table of solutions for each of these, and I'll start you off here. For each of these, I want you to do a table of solutions like this. Remember back in Algebra 1 when you had to pick a value of x, and then you got a value of y, and then you plotted the points? You're going to plot the points, and you'll see what the curve looks like. I don't want to give it away. So I'm going to tell you exactly which numbers I want you to use for x. First, use 0. Then let's pick some positive numbers, 1, 2, 3. And then let's pick some negative numbers. -1, -2, -3. All right. So if x is 0, that would be what? That would be what? Well, here you're going to put, let me do it on a separate piece of paper. If x is 0, right, well, the f of x is like y is equal to 3 to x, right? We're using an xy table, so there's my y and an x. If x is 0, that's y is equal to 3 to the power of 0. Anything to the power of 0, you'll see is 1. Anything to the power of 0 is 1. You could check that on the calculator. 3. And those of you that have this one, this little arrow up here gives you this one here, exponent. 3 to the power of, see how it does that little arrow up there? 3 to the power of 0 is 1. Okay, so when x is 0, I got y is equal to 1. When x is 1, 3 to the power of 1, well, that's 3. When x is 2, 3 to the power of 2, that's 3 squared, 9. Right, so you're just going to plot these points, right? Here's the xy axis. They kind of did it weird. Here's x down here, and here's y. 0, 1, 1, 3, 2, 9. And then you're going to just keep doing this, and then you're going to do the negative numbers, and you'll see the sketch of the graph. Okay, so you're going to do that for number 1, number 2, number 3. You're going to make a what? For these 3, you're going to make a, actually for the other 3 too, a table of solutions. You're going to use these same exact numbers all the time. 0, 1, 2, 3. Negative 1, negative 2, negative 3. Oops, sorry, there it is. Now for the ones in the back, what is this? We don't want fractions. We don't want fractions. But remember what I was telling you earlier? I want just the base and an exponent. So for this one, like number 4, that says f of x is equal to 1/2 to the power of x, you're going to change that 1/2. Remember, I don't want 1/2. Let me do it over here. Remember, 1/2 I can change to what? Well, that's 2 to the power of 1. And then when you move that up, isn't that 2 to the power of negative 1? Yeah. So really, this is y is equal to 2 to the power of negative 1 with an x. Well, when you have a power to a power, you multiply. So really, I want you to change these 3. We don't want the fraction. I want a base and an exponent. This is really going to be y is equal to 2 to the power of negative x. That's what this is going to change to. I don't want you to see it this way. I want you to see it this way so that you have a base and an exponent, right? They're exponential functions. So don't use this one. This one will be what? F of x or y is equal to 2 to the power of negative x. Don't use that one. Use that one. And then again, you're going to do what? A table of solutions using the same numbers. 0, 1, 2, 3, negative 1, negative 2, negative 3. For all of them, for all of them. What's this one going to be? Well, that one eventually, when you move that 4 to the power of 1 up, that'll be 4 to the negative 1. So really this one's going to be y is equal to, right? Your f of x is your y, is equal to 4 to the power of negative x. That's the one you're going to be using. And you're going to make a table of solutions. You're going to plot the points, however it's going to look, and then sketch the curve out. That's it. That's what we're doing. That's the work for these. And you're going to do this for all. There's only 6, okay? All right. So what you're going to compare, hopefully, and you take a look, and you're going to see what happens when it's a positive x and what the graph looks like. And then when it's a negative x, and what effect does that have on the graph? Okay, that's the assignment. Thank you.